Okay, this is the M1 paper from May 2022. It's question number 8, which is the final question in the paper. It's, as you can see, fairly big vectors question. We've got work involving I and J notation. We've got velocity and time in here. Let's just make a start to it. Let's look at part A. First of all, it says we've got two boats, P and Q. P is travelling with a velocity of 15I. Q is travelling with a velocity of 20I minus 20J. And part A says find the direction Q is travelling in and tells me to give it in terms of a bearing. Okay, that's relatively straightforward. I'm going to use a quick diagram just to help me with this one. Now, I don't need this at the moment, but if I wanted to, P is just travelling at 15I, that's fine, but Q is travelling, okay, trying to draw it relatively accurately, Q is travelling so that this is 20I minus 20J here, and I can actually see that that's 45 degrees, but let's do the work for it. They actually want the bearing, so they want, if I draw the north line in here, that's the answer that I want. But what I'm going to do first of all is just to work out the acute angle there. And as I say, I can see it, but if you couldn't, if it was different values, we would say tan alpha equals opposite over adjacent equals 1. So that means that alpha is going to work out to be 45 degrees, which is the bit that I could see. The bearing then is given by 90 plus that 45 is 135 degrees as my bearing, my answer for part A. Part B says the boats are now modelled as particles. P starts off at the origin. Q starts off at the point 200J. And it says, can we work out if the position vector of P is given by P and the position vector of Q is given by Q, can we work out what PQ is going to be? Yeah, we can. Let's just do a quick bit of sort of teaching, reminding you that if we've got a situation where I've got P and Q, so P's here and Q's here, and I've got those two position vectors. That's horrible handwriting, isn't it? I've got those two position vectors, P and Q there, then PQ is always given by Q minus P. Is it? Yeah, because if I want to go across there, what I do is I go down there and then up there. So I go minus P plus Q, that is minus P plus Q. But I just remember it, and I would suggest you remember it as being Q minus P there. So what that means, actually, let's just get rid of this bit. What that means now is I've got to work out what Q and P actually are. So they said in the question, I'll just change the colour of this just for a second so that we can see where P is. P, down the bottom here on the axis, is P here, starts off at the origin, and this has got a velocity of 15I, so that's what P is, whereas Q is starting up there at 200J and has got the velocity that we said before of 20I minus 20J. In more complicated questions, that might be quite helpful to draw that diagram out. So I've drawn it out even though in this particular one, it's not really helping me massively. The other thing I'm going to rely on then, let's get back to my normal colour for pen, is, I call this the vector equation of a line, but R equals R0 plus VT. If I want to find where R is going to be, I say, where does it start off from? That's my R0. R0 would be 0 for P. It's going to be 200J for the Q one. So R0 is the start position, and then add on your velocity times by time. So that should be something fairly familiar to you. So if we do this for P, I'm going to get P equals, well, R0 is nothing, and then it's just 15I times by T, brackets. So in other words, P is equal to 15Ti. That's a better way of writing it. For Q, let's do that down here, I've got plenty of space. For Q, again, I'm going to do R equals R0 plus VT. I'm going to get Q equals R0 is my 200J, where we start from, and the velocity this time is 20I minus 20J, all times by T. So let's just tidy that up, be careful. So I've got that as being 20Ti, and with J's, I've got 200 minus 20Tj. And then straight away from the teaching that I did 2 seconds ago, this is just going to be Q minus P here. So if it works out to be Q minus P, it's 20Ti plus 200 minus 20Tj minus 15Ti, and that tidies up quite neatly. The 20Ti and the 15Ti gives me 5Ti, and the other bit 200 minus 20Tj. That hopefully, well not hopefully because I've done it before already, that's what we've got there. So 5Ti, excuse me, plus 200 minus 20Tj. So that's PQ. So it now says find the bearing of P from Q when T equals 10. Well, first of all, let's work out what we're doing when T equals 10. So part C, at T equals, not 0, at T equals 10, PQ is going to be equal to, put T equals 10 in, 50I plus 200 minus 200J. Oh, okay, so that's just 50I. Well, if PQ is 50I, that's just going straight across. So if that's going straight across, we have that situation for PQ. Let's just go back and check what they're asking for. They want the bearing of P from Q. So if I'm working out that bearing now of P from Q, you put your north line at the Q from Q. So that bearing there, the bearing is going to be equal to 270 degrees. Don't need to do any tan, sine or cos for that. We can just see that straight away. Okay, it's an interesting answer for part C. And then what does part D say? Long question. This part D says, find the distance between P and Q when Q is northeast of P. Yeah, again, so a little diagram just helps for this bit here. Let's just do this here. So what we're saying is we've got this scenario, and this works if it's northeast, if it's west, if it's southeast, southwest, any of the compass heading directions. We can normally do something quite clever with this, that if this is northeast, what that means is that however many across there, I'm going straight up there the same value, because it's 45 degrees, it's cutting north and east in half here. Now this shouldn't be new to you, you should just be something that you know already, that if that's northeast, then what it means is, and let's say this to the examiner, if northeast, then I component will equal the J component. Okay, I'm going to get 3I and 3J, 10I and 10J, something like that, but I'm going to get the same values there. So what I can do is go back to my PQ, and what was my PQ? So PQ was 5Ti and 200 minus 20Tj. What I can now say is that the 5T part must be equal to the 200 minus 20T. So just that's easy, just rearrange that. We're going to get 25T equals 200. We get T equals 200 divided by 25, that's 8. So after, just check again the answer. Make sure that we're answering the question. Find the distance when PQ is northeast of, sorry, when Q is northeast of P, what I've done there is to find the time. So put that back into PQ now. Where was PQ? So PQ is now going to equal 5 times 8I and 200 minus 20 times 8J. Work out that that's 40I and it's 40J actually. And then what we want is the actual length. We actually want the length from P to Q, which is nice and easy. That's just the modulus of PQ, which is the square root of 40 squared plus 40 squared, which works out to be equal to, do it on your calculator, 40 root 2. Just check and see what it says in the answer scheme. If it doesn't say anything about decimal places, significant figures or exact values, don't say anything there for that one, then it's up to you what you can put down. We'll leave it as 57. And then finally, part E, find the times when PQ are 200 meters apart. So again, we go back to our PQ that we had. So we've got PQ is equal to this thing here. And what I now want is for the length of that to be equal to 200. So if I want the length of that to be equal to 200, that means the square root of, just be careful when we're doing this, goodness sake, just be careful writing this all out so we don't make any algebra mistakes here. 5t squared plus 200 minus 20t squared, that's going to equal to 200. Or in other words, multiplying out the algebra, 25t squared, that's not very nice as to what that works out to be when we're doing that. Just be careful when we're going through and doing it. That's going to be 40,000. You take your time. I've already done this. Minus 8,000t plus 400t squared. Okay, all of that then works out to be 200 squared. So all of that works out to be equal to 40,000. And then what's really useful is those two are going to cancel. So we actually get 425t squared minus 8,000t equals 0. And we can solve that. That's a nice easy one. Take t out. 425t minus 8,000. 1,000, not 100. Which gives me t equals 0, or 425t minus 8,000 equals 0. And that just rearranges to t equals 18.82 seconds. Go back, what did we need? Find the times when. Okay, so it's, let's not miss off the other one. It's t equals 0, or t equals what we just said there, which was 18.82 seconds, maybe 19. Actually, I would put 19 seconds. I think that would leave us 18.82. Okay, so big question there, but hopefully each separate part relatively straightforward and a good question to learn from for anything that might come up in the actual exam that we've got. Okay, hope that makes sense.